Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morals Math Corner. Today we're going to learn about the complex number system. So let's get right to it. Up to this point, we've only been working with what we call the real number system. Those are real numbers. But today, we will learn about what's called the complex number system. Now, let's try to go back in time. Recall that if you were given an even index radical with a negative radicand, so in other words, if you were given the square root of -3 or the fourth root of -17, those are even indexed with a negative radicand. You couldn't work with that. That would be just what's called no solution, right? Or not real. You can't do it. But now we do recognize these as what's called an imaginary unit, which is represented by the letter I, where I equals the square root of -1. I squared equals -1. I to the third power, or I cubed, equals -I. And last but not least, I to the fourth power equals 1. This is going to help us out a lot, so make sure you remember that. Now, a complex number, or complex numbers, are numbers of the form a plus bi, where a is the real part and b is the imaginary part. So, for example, you could have something like 5 plus 6i. That would be a complex number. Just a unit by itself is I, but when you're talking about a complex number, you're using a real part and an imaginary part. When simplifying imaginary radicands, simply remember that the square root of -x, there is a negative here. Remember that the square root of -1 equals I. So anytime you see a square root with a negative, you're going to go ahead and replace that negative by pulling it out as an I. So it would be I times the square root of x. So the square root of -6, well, this is simply going to be I times the square root of 6 because I can't break down the square root of 6 any further. Square root of -27. First thing I'm going to do is I'm going to go ahead and get rid of that negative inside of the radical. So that's going to become an I. Now times the square root of 27. And now I can go ahead and break this up. This is 3 times 9. Square root of 9 is 3. So I've got 3i with a leftover of 3 inside the square root. Square root of -64. Well, that's just straight up 8i. Why? Because the square root of -1 is I and the square root of 64 is 8. Square root of -18. Well, here I'm going to go ahead and get rid of, or simplify rather, the square root of -1 as an I on the outside, leaving me with a square root of 18. This is 2 times 9. Square root of 9 is 3. So I've got 3i with the square root of 2 left over. And that's how you simplify negative even index radicals. Okay, when simplifying complex numbers, you must write the simplified answer in standard form, a plus bi. So what does that look like? Well, in this particular case, I've got 4 minus the square root of -36. Well, this is going to become 4 minus the square root of -36 is 6i, and we're done. 8 plus the square root of -32. This is 8 plus. We're going to take out an I first to get rid of that negative inside the radical. And then if you remember, this is 2 times 16. Square root of 16 is 4. So this is 8 plus 4i with a square root of 2 left over. 4 minus 20, square root of 20 divided by 2. Please remember that this 2 in the denominator distributes division to both the 4 and the square root of 20. So you could rewrite this as 4 over 2 minus. Remember that 20 is 4 times 5. So the square root of 4 is 2 with a square root of 5 divided by 2 as well. And that will equal 2 minus square root of 5. And there you have it. When adding or subtracting complex numbers, simply add or subtract the real parts with the real parts and the imaginary parts with the imaginary parts. It's literally that simple. But please remember, whenever you're adding or subtracting, Be cognizant of whether or not you're subtracting or adding, because if you're subtracting, please remember you must distribute that negative. So you would rewrite this as negative 3 plus 8i minus 7 plus 3i. Combined like terms, this is going to be negative 10 plus 11i. And there you have it. Next, we've got a plus here, so we don't have to change signs. I've got a 6 plus a negative 4, so that's 2. Square root of negative 49 is 7i. And then I've got a 3i here, so that's plus 10i. Okay. For here, I've got a negative again, so I'm going to distribute that negative. So I'm going to rewrite this as 5 minus 10i plus 7 plus 6i. Real number to real number, 5 plus 7 is 12. Imaginary number plus imaginary number, negative 10i plus 6i is negative 4i. And you're done. Okay. When multiplying complex numbers, treat the I like a variable. Remember that when multiplying the same base, hint, hint, you keep the base, which in this case would be I, and you add the exponents. And another little friendly reminder, remember that I squared equals negative 1. So when I'm distributing, I've got 5i times 4, that's 20i, minus 10i squared. Because 5i times 2i, 5 times 2 is 10, I times I is I squared. Please remember that this I squared becomes a negative 1. So this is really 20i plus 10, which would be rewritten as 10 plus 20i. Now you may say, how did you get that positive? Please remember, once again, that this I squared is really a negative 1. And a negative 1 times that negative 10 is that positive 10 here that we have. All right, next, we got negative 2 times 3, which is negative 6, plus 2i. 6i times 3 is plus 18i. And 6i times negative I is negative 6i squared. Remember that the I squared is a negative, so this really becomes a negative 6 times a negative 1, which is positive 6. And then my negative 6 with this positive 6, those cancel, and I'm left with 2i plus 18i, which is 20i. Okay, square root of negative 36 is simply 6i times square root of negative 9 is 3i. 6 times 3 is 18. I times I is I squared. I squared equals negative 1, so this is negative 18. Please do not multiply the insides first. Whenever you have a negative radicand inside of an even radical, you must simplify the imaginary number first. Okay. Another example here. 3 times 2 is 6. 3 times 3 times a negative square root of negative 5. Well, remember that the square root of negative 5 is really I times square root of 5. So this is negative 3i square root of 5. Then I have the square root of negative 25, which is 5i, times 2. So that's positive 10i. And then I've got my 5i times I square root of 2. So my 5i times I will be 5i squared times the square root of 5. Let's simplify this. I've got 6 minus 3i square root of 5 plus 10i minus 5 square root of 5. And that is it. I do not have any like terms. Okay, that's a great one. That is a great one. Okay, last but not least, let's talk about conjugates. Complex conjugates are the same as regular conjugates, except for the fact that you are working with complex numbers. In order to find complex conjugate of a given complex number, simply write the given complex number in standard form and change the sign of the imaginary part. Period. That's it. It's that simple. So I've got 5 minus 3i. The conjugate would be 5 plus 3i. I've got here 2i plus 7. The conjugate would be 7 minus 2i. Okay? And then remember also that when you multiply a complex number by its complex conjugate, you're going to create what's called a difference of squares and are left with the following product. Remember that when you have a difference of squares, it's always going to be the same rhythm. It's the first term squared minus the second term squared. Check. Okay? So let's get to this. So I've got 8 times 8, which is 64, plus 40i, minus 40i, and then minus 25i squared. Well, the 40i and the negative 40i cancel, and I've got 64. Negative 25i squared becomes positive 25, and that would be 89. Now, that is going the long way, and there's not a single problem with that. However, wouldn't this be a lot easier if you just remembered the difference of squares? Hey, wait a second. These are the same exact binomials, but one is being added, one is being subtracted. So I'm going to take my first term and square it. That's 64. Minus my second term, which is 5i, and square it. That's going to give me 64 minus 25i squared, which gives me 64 plus 25, which gives me my 89. So it really does not matter, okay, as long as you have a difference of squares there and you recognize it, you can go the long way or using the formula. So once again, the long way here, we'd go 2 times 2 is 4. 2 times 4i is 8i. Negative 4i times 2 is negative 8i. Negative 4i times 4i is negative 16i squared. I squared is a negative. Negative times negative 16 becomes 16. 4 plus 16 is 20. And the 8i and negative I cancel out. Now let's do this, in my opinion, the more efficient way. First term squared, 2 squared is 4. Minus second term squared, 4i squared is 16i squared. The 16i squared becomes negative 16 times a negative. That's 4 plus 16, which equals 20. Okay? So when you divide complex numbers, you must write both the numerator and denominator in standard form, and then rationalize the denominator by multiplying both the numerator and denominator by its complex conjugate. Since you can't have a radical in the denominator, okay? Remember that I equals the square root of negative 1. So, in this particular case, I want to get rid of the denominator, so I'm going to multiply by the conjugate, which is 2 minus 3i. Then I'm going to distribute. Negative 4 times 2 is negative 8. Negative 4 times negative 3i is 12i. I times 2 is positive 2i. I times negative 3i is negative 3i squared. Negative 3i squared becomes positive 3 because I squared is negative 1. Negative 8 plus 3 is negative 5. 3i plus 2i is 5i. And in the denominator, since I have a difference of squares, first term squared is 2 squared is 4, minus second term squared is 9i squared, which becomes a negative 9, so that becomes 4 plus 9, and I've got negative 5 plus 5i over 13. Bam! There you have it. Okay, next. Let's go ahead and use the conjugate to eliminate the denominator. So I'm going to multiply by 1 plus 3i. I'm going to go ahead and FOIL. 4 times 1 is 4. 4 times 3i is 12i. 3i times 1 is 3i. 3i times 3i is 9i squared. That becomes negative 9. So that's negative 5 plus 15i divided by first term squared is 1 minus second term squared is 9i squared, which becomes a negative 9. So that's negative 5 plus 15i over positive 10. I can go ahead and take a 5 away from everything, giving me negative 2 plus 3i over 2. And if I really wanted to go one further, I could divide this 2 to both the real part and the imaginary part, giving me negative 1 plus 3i over 2. Bam! And that's the real simplified version of that. And then sometimes they'll just give you one term, just an imaginary unit in the denominator. Don't make a mountain out of a molehill. How do I get rid of an I? Let's go ahead and multiply another I. You don't have to worry about the 2. So I've got 5i plus 6i squared over 2i squared. So that's going to give me negative 6 plus 5i over negative 2, which will give me 3 minus 5i over 2. Remember that negative 2 distributes to the negative 6 and the 5i. All right, now I know I said this before, but I promise this is last but not least for sure. Evaluating powers of I is very easy if you remember the following facts. I equals negative 1. I squared equals negative 1. I'm sorry. I equals the square root of negative 1. I squared equals negative 1. I cubed equals negative I. And I to the 4th equals 1. Whenever you have to evaluate a power of I, simply divide the given power by 4. That's right. And use the remainder as the new exponent of I and evaluate from there. It's literally that simple. So I to the 38th. Well, I'm going to go ahead and divide. So let me get out of highlighter. I'm going to divide 38 by 4. It's going to go in 9 times, which is 36. And I got 2 left over. So that means that I had 9 sets of 4 i's. So that's a 1 that came out 9 times. So 1 times itself infinitely a number of times is 1. So what am I left with though? I'm left over with a 2. So that's the exponent of I that I'm left with. So this equals I squared, which is really negative 1. 98. Well, when I go ahead and divide 4 by 98, what am I going to get there? I got a 2. Then I got my 4. I got a 2 left over again. So I'm left with I squared, which is negative 1. This should not be that complicated at all if you remember what the i's mean. 101. Well, when I go ahead and divide 101 by 4, I get 25.25. So that means when I go in 25, I'm going to have 1 left over. So that means I have I to the 1st power left over. And then I to the 43rd, well, 4 goes into 43 10 times evenly with 3 left over. So that means that my answer is I cubed, which is negative I. And there you have it, complex numbers. Thank you so much. I hope you learned a lot. Have a great day. Come back anytime now. Bye-bye.